Well, hello, everybody. Whether it's good morning, good afternoon, good evening, thank you for enjoying our latest investor briefing on decarbonizing low temperature industrial heat. This follows on from previous investor briefings we've done on thermal energy storage, on long duration energy storage in general, and also just as a little FYI, coming up at the end of November, we have an investor briefing on investing in India, which is something we're spending a lot of time on. So today I'm joined by Victor Ghitescu, who is our specialist in low-grade industrial heat. And also, here's just a snapshot of some of the folks that are on the call. We've had a pretty amazing turnout of 200 registered folks for this webinar today. So this, what tells me is you've got investors, you've got large corporates, who are customers, and you've got technology companies and in the adjacent areas of thermal energy storage. So I think from what I'm hearing, I think this is an area that's gathering more and more attention, deserved attention. We've got an amazing panel for you today, which I'm going to have them introduce themselves in a couple of minutes. And they represent, the breadth of this, the capital side of the business, the technology side of the business, and also the RTC, which is an organization that's really sort of trying to pull it all together. So, but I'd like to kind of start with some of our thoughts as we work through the space. When you look at what we call low temperature heat, we put it at 200 C and below. And you look at that, and that's actually a $300 billion market, right? And it's a good, and Victor will get into this in a little bit, but industrial heat is 20% of greenhouse gases, so we've heard, but the 200 C below and below is actually a very large proportion of that. The other exciting thing on this is you've got a very high efficiency, and the reasons for that, Victor will come into it. But if you look at kind of the replacement market, there's somewhere shy of a million boilers out there, industrial boilers, and that's the target over a period of time to replace. So let me hand over to Victor to kind of run us through some of the numbers.
Thank you, Andrei. So as most of you know, there's been a lot done to decarbonize the power and transport industries in the recent past, and there's still ways to go. However, we think that today, the biggest opportunity lies in decarbonizing the industrial sector, where about 3/4 of emissions come from industrial heat. And about 40% of this heat is below 200 degrees Celsius, which makes this portion of the market an ideal candidate for the use of heat pumps. As you can see, both the European Union and the United States follow a similar distribution when it comes to their process heat demand, with the European Union having about 40% of its demand between 100 and 200 degrees C, whereas the United States has about 50% of demand below 200 degrees. What's also interesting to note is that although most industries use some sort of low temperature heat, there are a few candidates that stand out for immediate decarbonization using heat pumps, and that will be the food and beverage sector and the pulp, paper, and print one. Another interesting way to look at this equation is, as a potential heat pump manufacturer, as you increase your maximum potential temperature output, you unlock a bigger market share. As you can see here, when you go from above 150 to about 200 degrees Celsius, you unlock an extra 30% of the market. That's mostly due to the fact that the higher temperature allows your heat pump to be used in a wider range of industrial processes. Look, most of you know that this technology, heat pumps, have been around for more than 100 years, but only recently have they managed to reach what we call high temperature, so anything above 100 degrees Celsius. This is mainly due to the fact that there have been significant improvements in the technology, mostly around compressor technology or even refrigerants. And with many thanks to Cordin Arpagos from OST Zurich, who has kindly provided us with this data, you can see that in the past 6 years, the number of companies offering these high temperature heat pumps has more than doubled. Not only that, but also the maximum temperature output for these products went from about 165 degrees to more than 250. And you can see that manufacturers are concentrating on higher and higher installations. So we're seeing more 1 megawatt and above installations in the market. When you look at the economics of a heat pump and you compare it to other technologies, be them fossil fuel based or not, you're going to see that heat pumps do hold a significant advantage, especially after you've depreciated the initial investment capex. In essence, heat pumps use less electricity, as you can see here. As Andrei was saying at the beginning of the presentation, this technology has a coefficient of performance of above 100%. That means that partly they use some of the waste heat from other industrial processes, thus requiring less electricity. So this means for the end client that they're gonna basically be paying lower bills while also being less sensitive to energy price fluctuations. And I want to say that we want to thank Michael from Anyos for providing us with this data. And I'm sure he's gonna be able to offer you more color on his findings on the discussion following our presentation. Lastly, I want to say that as we've put this presentation and webinar together, we've spoken to a lot of companies and investors and even industry associations. And most of them agree that you're going to have more and more integrations in the future between heat pumps and some sort of energy storage, be it thermal or even lithium ion. We think that this will allow end clients or customers to achieve the lowest potential OPEX, lowest potential levelized cost of heat or steam, while also making good to their shareholders and stakeholders on their net zero initiatives and promises.
Okay, so just coming back to the capital raising side of this industry, today we're really focusing on the industrial side because I think that's where a lot of promise is. But we also thought we'd share what's happening on the residential side, because there is quite a bit of activity. It's a very distinctly different business. But I think given what we're hearing from seeing on the tech side, seeing on the fit with the customer and how costs are coming down, I think that from an investor standpoint, this is a place to start focusing, because I think in 25, 26, 27, we're going to see quite a few capital raises of a size that might fit some of the bigger investors. But now's the time to start having a look at this. But you could see this trickle. We saw this in other sectors, like on the thermal storage. But our hunch and our thesis, I guess, is this is going to happen here as well. So it's good to get prepared and start to get to know the companies. Okay, so in terms of, before I hand over to the group and introduce them, some of the areas that we thought are quite pertinent and will pop up in the discussion today is really about where's the technology going? What can it do? What are the implications for that? What's the technology readiness? Is there a barrier of lack of awareness? And how, whether it's at the customer end or at the investor end, and what can we do to kind of help that along? What are the roles that the regulators have to play in this? Also, there's the usual one of cost. How can we bring them down? And then it's really about the complexity. I mean, this is more complex than a gas boiler, that's for sure. But we can make it simpler. And how do we do that? And then there's also, I think Victor will talk to us, Victor Weisberg will talk to us really around the perception of risk and how investors, you could bring different classes of capital when you box the risk appropriately. So these are just from our perspective, the things we were picking up that are kind of, I believe, will be discussion points as we go along. And of course, I'm sure there's others, if you have questions, please join in the chat group. And I think the panel will also kind of broaden out with some of their experiences and other, elements to this. So let me start by introducing the panel, and maybe I could start with Blaine. Blaine, I've always seen you as, a big supporter of, industrial heat generally, but in heat pumps and specifically. So I think it'd be great if you could spend just 2 minutes on yourself and on what the RTC does to support this.
Thank you very much. So I'm Blaine Collison. I'm the executive director of the RTC. The RTC is, in fact, a global buyer-led coalition focused on decarbonizing thermal, particularly industrial thermal, with renewables. We work on these three big lanes of effort, right? Technology, market development, and policy. The bottom line here really is working with our key stakeholders, particularly the buyers, and we'll look at them in just a moment, to actually drive forward on implementation, right? Our end game is more projects in the ground, which leads to decarbonization. The RTC is co-convened by three organizations, C2ES, David Gardner and Associates, and the World Wildlife Fund. And if you go to the next slide, please. We are buyer-led. We exist because a small group of these companies came to us and said, we have a problem. We don't understand how to approach decarbonizing heat. These are our members. It is a global group. The full range of industrial process heat is represented here. Some of the sectors that Victor flagged as being particularly interesting opportunities are obviously sitting here, right? Food and beverage. Pharma looks a lot like food and beverage. Chemical sector, pulp and paper, right? And then the full range of global manufacturing. All of these companies are working to figure out, what technology do I deploy, where, in what order, how do I pay for it again, and with whom do I work? They are joined on the partnership side here in the RTC by these solutions. These are the technology and deployment innovators. You'll hear from some of them today. This is also an amazing global group. And then my last slide is just my contact information. Yeah, which we'll share later. But that was 2 minutes and 1 second, I believe.
Blaine, you're a star. You set the pace. Okay, let me turn over to Atmos to Dolf, MD for Europe. Dolf, thank you for joining us.
Sure, thank you, Andrei. Thanks for having me today. So my name is Dolf Joekes. I'm the Managing Director for Atmos Europe. We're based here in the Netherlands. Company was founded in Colorado and is headquartered there. So the problems that we're trying to solve and that we see in the market for factories, let's say industrials trying to decarbonize, are that e-boilers, as some of you might know, have a limited efficiency, and that heat pump solutions typically rely on integrating waste heat. And while that is a good thing to do, a smart thing to do from an energy efficiency perspective, we believe that we are overlooking the capital efficiency when we do that. So we set out to develop a modular, fit anywhere, packaged heat pump solution that is truly scalable and that doesn't require a bespoke engineering project for every facility that the customer wants to decarbonize. So we call it Boiler 2.0, if you can go back one slide, sorry. And so this is a modular air-sourced steam heat pump that allows us to do this. And we do not rely on waste heat. We like to call it a product, not a project. Okay. And in the next slide, you can see that we've done some research on what we call the hidden cost of installing waste heat-driven systems, right? So not just the engineering costs required to be integrating these systems, but also the increased facility downtime means that if a facility typically has waste heat available that is below, let's say, 60 degrees Celsius, it's typically not economical to be integrating a waste heat-driven heat pump just because of the increased capital cost and the increased downtime.
Right.
Okay. And as a bonus, in the next slide, in addition to providing low-cost steam, our Boiler 2.0 system that you can see here on the left can be integrated with a cooling tower, for example, or a chiller, thereby offering additional benefits to the lowest levelized cost of steam for your system. Excellent. So if you're interested in our solution, please shoot me a note, dolf@atmos0.energy, and I'd love to talk.
Yeah, we'll share all the contacts. So I'm sure people will want to get a hold of all of you. Thank you very much, Dolph. That was great. So if I could turn to Michael at Anyos. So
Yes.
tell us a little bit about your what Anyos is up to. But first, congratulations, Michael, on the award that you received just very recently from the European Heat Pump Association. Well done.
Yeah, thank you very much. It was a great surprise, bit an honor to get it. The competition was tough. Yeah, but very briefly about Aneo. The Aneo is basically a renewable energy company located in Norway, where we produce around 2 terawatt hours of renewable green electricity and are managing around 8 terawatt hours or so per year on the Norwegian market, basically. That's basically upstreams where we are producing electricity, and downstreams we have different assets where we are basically look into the aspects of how to bring this electricity in an efficient way to customers, from everything like charging of electric vehicles, but also Aneo Industry, which is basically steam producing heat pumps. Aneo Industry started 3-4 years ago as a project where the challenge or the target was to generate a heat pump that is generating steam and supply to an industrial customer, Fellesköpet, and utilizing excess heat from the same factory. And that was exactly what we then won the prize for this system, which you can see on the next slide, at least parts of it. So we were designing a heat pump system based on the standardized components and the natural refrigerants. And this heat pump can utilize waste heat 30 degrees down to 15 degrees if necessary, and to supply basically steam back to the factory with quite a good Carnot efficiency. So I must disagree a little bit with what Dolph was saying. So we are reaching with this heat pumps, we are actually exactly utilizing waste heat below 30-40 degrees and getting a COP of 3 and supplying it back to the factory. And when we talk about if it's efficient or not, or economic or not, we have, of course, to see that this is a standardized unit now for 1.5 megawatt of steam supply. It's upscaled up to almost 5 megawatt. And in that capacity range, I think it makes a lot of sense also economically to utilize this heat pump.
Perfect.
And on the last slide which I have prepared, I wanted to outline the main aspects. We were not doing this as a pilot project, started this 3 years ago. And we wouldn't have been there where we are today without Fellesköpet. They really needed a client who was willing to put the little bit necessary, required extra effort into the project, so that we now have actually also a product. And some of the main aspects, to my surprise, is actually that we are now installing these heat pumps in locations where there is a limited electricity grid capacity available. When we started the project, we were mostly focusing on reducing and substituting fossil steam or fossil boilers. How many projects are started with the aspect, okay, we don't have enough electricity where we want to have our factory or where we have our factory, so we're now forced to use heat pumps. And last but not least, we also think need to outline that, in my opinion, heat pumps utilizing natural refrigerants are the future. There are a lot of aspects speaking for that. And for me personally, I always was a big fan of using water as refrigerant. It's very safe. You even can drink it. And it's also very cheap. So compare that, there's a lot of advantages. And that's exactly what we have been doing with our steam producing heat pump system.
Excellent. Thank you, Michael. That's very thorough. Excellent. So if I could turn now to a company you may not have heard too much about yet, because I think they've been in stealth mode. But David Terse is going to tear the cover off and tell us about what's going on at Carmen.
Nice to meet you all. David Terse, co-founder and CEO of Carmen Industries. We're building a mass manufactured heat pump that is standardized, fits inside a shipping container, does 120 megawatts. And really the way that we're able to do this is we're leveraging advancements out of the electric vehicle and aerospace sectors. So we're taking cutting edge turbo machinery from the likes of SpaceX, Rocket Lab, high-speed power electronics, advanced manufacturing techniques from Tesla and Rivian. Hence why we're based in Los Angeles. All these companies are within about a 25-mile range of here. And we're building a product that's highly aligned with the customer. And so To the previous person's point, we are also doing waste heat recovery and integration into our system, because while we look at the CapEx being a major function out of these systems, when you talk about the actual long-term cost of one of these systems, it's energy. And so you need to have the highest efficiency possible out of your system. And so we're targeting industry leading COP levels at a fraction of the CapEx cost due to our mass manufacturing of this system. And talking about that integration piece, we build about 95% of this system in our factory. We deliver you a shipping container sized unit that can handle 1 to 20 megawatts, as I said. So this is a fraction of the size. It gets dropped off at your site, and the actual integration piece is much more simple. So very minimal downtime for a customer, very high efficiency, so that drops your OpEx of the system, and a CapEx that's a 60 to 70% decrease over the status quo today to help eliminate those Scope 1 emissions as well. And then, of course, highly aligned with the government. Being able to reduce emissions is a goal of all of our customers, but at the end of the day, it's still a financially driven decision. So we're trying to check off both those boxes for them. If you go to the next slide. And really the only way we're able to do that is being able to pull the team together. So led by my co-founder, Dr. CJ Kalra, who is former head of technology at Antora, spent time at Heliogen, and then began his career at GE Research working on supercritical CO2 turbo machinery. The rest of our team, Vince coming over from 5 years at Rocket Lab, director of space systems. Willem, after 4 years at Heliogen, as director of concentrated solar. Our turbo machinery lead, Tade, has been building these systems for almost 20 years now in the oil and gas industry. We brought over to do in-house motor development, Vinay coming over leading a 100-person team at Rivian. And then Shiva is coming from a relativity and SpaceX background, leading our modeling and simulation, as well as Andrei coming from Joby. So really, we believe that leveraging advanced technology out of other sectors and bringing it here for the first time is really how you can push that limit on efficiency at a fraction of the cost. Excellent.
Quite a team, David. Thank you. So if I could turn now to Victor, are you with us? Victor Weisberg, director of Susi. And Susi, for those of you know, is a very prominent infrastructure investor. So maybe, Victor, tell us a little bit about what you're doing in this space, in particular, this sector of low-grade temperature.
Sure. So Susi Partners is a fund manager focused on sustainable energy infrastructure investments. The firm's been around for about 15 years, and we offer kind of equity and credit solutions to finance the energy transition. So, for example, we'll back developers that develop renewable energy projects. We'll also back ESCOs that look for energy efficiency projects, and we'll also finance with credit instruments energy as a service sort of projects. We're one of Europe's most predominant energy efficiency investors. If you go to the next slide, then it's to kind of give you a sense of these sorts of energy as a service and energy efficiency as a service, because I think there's a lot of parallelisms with what heat as a service will ultimately look like. What we've observed is that industrial clients are sometimes reluctant to spend the CapEx to realize energy efficiencies. And this could also be heat efficiencies. And so through our credit fund, we've been able to finance over 800 million euros of energy efficiency retrofits that lead to an overall kind of energy savings. And what we'll do is we'll set up those contracts to be between 7 and 20 years, depending on the kind of risk associated with the infrastructure and the end customer, to split those cost savings through that efficiency update. Let's say we believe that heat is going to offer kind of a blue ocean to finance these sorts of retrofits. A lot of the people on this call are technology providers that are trying to convince those end customers to install their equipment, and Susi could be a financing partner to help make those decisions and realize those savings and CO2 benefits. So if you go to the next slide, it kind of covers a bit some of the risks and challenges around this contracting and as a service model. So a lot of it is around the contractual design, but it's important that let's say those infrastructure updates are done in a ring-fenced way. that there's intrinsic value in terms of those infrastructures that we install. The end customer is also looking for like certain performance warranties and that it's going to fit their processes, and so it's important that there's certain guarantees that are provided. But this is not something that Susi could provide. It has to come from, let's say, the ESCO that's delivering that heat service over a certain period. So there's a couple of these components that I think will make the discussion kind of relevant later on in the session. But I wanted to highlight that Susi's a specialist in designing these sorts of frameworks and could support kind of financing these installations for corporate customers.
Brilliant. Thank you, Victor. Very timely as well, I might add. So, and last but not least, I'd like to introduce Andrei Klochko from Airthium, quite an innovator in the space. So, Andrei, are you there? There you are.
Yep.
Thank you. Yeah.
Okay, so it was a great panel you assembled on this topic. Few people in the world really understand the size and the timeliness of the opportunity of heat pumps. So that's something that we at Airthium also captured quite early. Our approach is quite different in terms of technology, but it has a lot of benefits. So we went after the Stirling engine approach. So instead of liquefying and gasifying something, we compress and expand the same helium bubble. This allows us to adapt to any temperature. The same machine can work on any different temperatures that the client wants, either as delivery temperature or as waste heat temperature. And we can go up to 550. So of course, the higher you go, the lesser the efficiency, but also the higher you go, the less solutions there are. So people up there who want to decarbonize, well, they don't have many other solutions than what we have. The other benefits about doing what we do, so using a Stirling engine as a heat pump to provide heat for the industry, is that eventually you get able to do something else, which is basically using all the new heat storage companies, which is the other side of the coin of how you decarbonize heat. You try to tap all those very low prices that you can get throughout the day. You can amplify that storage because, let's say, Antora, which David spoke about, they store at 1800 Celsius. That's huge. But clients don't need that. They need that 200 or 300 Celsius. So going down all that temperature range, you can essentially increase the heat flow by conserving the entropy. So for 1 kilowatt hour stored, you can get 1.2, 1.3, 1.4 kilowatt hours given to the client. And because of that, that's how you leverage all the other costs of the system. You essentially multiply its efficiency. Also, one thing that we do is that we can get to very small sizes. Even at 100 kilowatts, it works. And that's because, contrary to all kinds of turbines, we have a near isosomal approach. We're actually the first, as far as we know, the first to actually do this. When we compress and expand the helium, it doesn't heat or cool down by more than 20 Celsius. And that's really how we managed to have this great efficiency with a system that's very cheap, because essentially we also have conventional shell and tube heat exchangers, which no one could ever use in a Stirling engine, but in our case, it works. And basically, by combining all of those things, we're able to have this machine that adapts to any load, even batch processes, so we can heat up and cool down, for example, products that you have to preheat for an oven, or, for example, wind turbine blades that you have to cure. All kinds of things become possible with this approach. So we're a small team. We're based in Europe. Because of that, operation costs a lot less as well. And we are getting firmly towards commercialization.
Brilliant. Thank you, Andrei. That's really exciting. So before I turn to the questions, all these slides will be available. You can get them on our site in the media section. So, and I think we will also make sure that the contact details of all the panelists will be available if you want to reach out to them directly. Okay, well, now I think we've raised a lot of issues in terms of, cost or temperature ranges, scale. I think maybe let's now sort of step back a little bit, and maybe Blaine, you just hosted a pretty significant event in Washington in the end of September, in thermal generally, but you had a pretty big turnout. Tell us a little bit about what well, one kind of the mood in the industry, but also really what's the outlook over the next, I don't know, 12, 24, maybe even longer months for this sector generally speaking?
Yeah, good questions. And wow, what an amazing overview. I was furiously typing notes here. So from where I sit, and as you say, we're coming on the heels of the annual RTC summit. We sold out this year for the first time, which was amazing. So we had 300 and some people come from around the world to DC to talk about industrial thermal decarbonization. Fantastic, right? Mix of technology providers and third-party project financiers and consultants, and of course the end users, right? So the end users, those global industrials whose logos I shared earlier, they all have climate goals. They're different, they're on different timescales, but they all have goals, and they are all trying to figure out how to get from here to there. So thinking back to say the last couple of years, and so where my own members are, the conversations have absolutely moved from we really have to do something and we're trying to assess to, all right, no, really, what do we do, where, when, in what order, how do we get to scale, right? How do we do some pilot projects that turn into scale quickly? How are we going to address CapEx shortages? We want to find the right technology mix. We're willing to have some lessons learned here, but we need to get going and develop those lessons learned so that in fact the curve starts to bend very sharply. They're all looking to deploy.
So if you take it, maybe I'll turn it. Thank you. That was really great, Blaine. But if I turn it over to Dolph, David, Andrei, and Michael, sort of, who are at the customer end, right? Talking about an actual deal rather than the macros we talked about, 300 billion market, great temperatures, that's all the cool stuff, just the pie charts, but really, and maybe I'll start with you, Dolph, because you're actually in the middle of a project, right? And I think it's kind of what the numbers sort of speak for themselves, but getting a customer to move forward on it, what I don't want to be first kind of thing, but maybe tell us a little bit about the hesitancy, but also the way around it, or maybe it's not today, but in the future. And I think maybe then I'll see what David has to say, and Andrei and Michael as well. So maybe pass the same question around to you all.
Sure. Thanks, Andrei. So I saw New Belgium on your slide, Blaine.
Yeah.
So they're our first customer, and we're going to deploy our first system with them within 6 months from today. So very exciting. If I look at the conversations we've had with them, but also with customers here in Europe. So here in Europe, as you mentioned earlier, heat pumps aren't a new technology per se, but the fact that we can now produce steam with them is fairly new. So it's still an emerging industry. So what we try to do at AtmoZero is to use as many off-the-shelf components as possible and really focus on our core IP, which is around the compressor and the control strategies for our system. So we try to reduce the technology risk to the customer by using as many off-the-shelf components as possible. And then most of these customers will want to see a unit running. So whether that's our prototype that we had built in less than 18 months in Colorado, and we have had under test for the last 12 months now, or whether it's a customer unit at New Belgium or soon here in Europe at a customer side there. It really helps to take away some of the concerns that these customers might have. And they vary, in my view, they vary from reliability. Obviously, it's a new technology. So what does it do in 10, 20 years? They look at the all sorts of like serviceability. And what we try to do is keep the buyer's journey as close to a gas-fired steam boiler that they're used to as possible. So they don't need to be outside of their comfort zone too much, if you know what I mean.
Yeah,
Yeah.
that makes a lot of sense. So maybe Michael, you also had quite a bit of customer interaction. Is that similar here in Europe? Or
I think a lot of aspects that Dolph was mentioning, I definitely meet when I talk to our clients here, as in particular that you have basically already a system in operation, so clients can come and basically touch it. That helps a lot to convince somebody that this is not just a fancy PowerPoint, but this is really working technology. Another aspect is, but we has also to see most of the clients we're in contact with, they already know that heat pump is a part of their solution to decarbonize their production processes. They're just not entirely sure how to integrate it, and maybe also how to do this integration in an efficient way that will not influence the production. And there is, I think, a lot of competence need, and where we come in to explain and show them how this can be done. Yeah. Of course, we are substituting a fossil boilers, which can easily supply a 10 bar steam at 180 degrees, and that's what they are used to. And when we now come and tell them, yeah, but we have to really do it here differently, we have to come from basically 1 bar steam and compress it only as much up as they actually need it on the production process, we pretty fast see that the added value is basically the in-depth integration of high temperature heat pumps, where we can show the client, okay, this heat pump, this steam supply, and how to do it in an in-depth integration, which requires certain, knowledge on the production process. What can you do? What can you not do? Said that, we see now also that heat pump, the steam that we can supply, for example, to the fellowship project, has certain advantages compared to a gas boiler. We can really have a dry steam, which is an advantage for the product and quality as well. So we are getting there that we can also not only outline, okay, it's more efficient, you save primary energy, but you also can outline, yeah, maybe your product is getting even better if you do it with a heat pump. And that's, of course, another aspect which we have to see. And that's only possible if you do in-depth integration and not just say, I supply to the main steam grid 6 bar steam or 10 bar steam. So that's one of the discussion points here. That is, or the main, I think most of the clients really like to have a sort of knowledge and need competence how to do an in-depth integration of a high temperature heat pump, and not just a supply at the factory wall. This
that learning curve and seeing it work somewhere else is always a big comfort, right? I don't want to be first, Anyway, Andrei, I saw you shaking your head. You're in agreement?
Yeah, so basically, we just visited a factory recently of a larger chemical plant players. They're making baking soda essentially. So they have this big reaction where they have to essentially heat some stuff and then cool stuff or in different places. And they have all those heat exchangers lying around and all this waste heat that they have to dump in a river where they can't dump it anymore. So sometimes when you integrate in the factory, it's not only about the calories, it's also about compliance. There are other projects with Canadian Saint Oil where if they don't improve their environment metrics, they will be forbidden to just dig and operate, and that's big for them. So they have to do something. Also, you have all this negative carbon oil. You have Oxy that bought Carbon Engineering for $1 billion. That's all about heat management as well. And they want to reduce the energy footprint of dealing with all that CO2. You have all those needs all around the place. Basically, we are getting into a blue ocean. I really agree with Victor Weisberg's point on this. Heat as a service, it's a blue ocean. And one of our investors, Arum, that's exactly why they invested. They want to fund it's essentially a Trojan horse. You put the heat pump at the customer site, and then suddenly you can sell them a bunch of renewable energy. So it's really something that a lot of players want to see. It's at the intersection of so many desires, and so it will be done no matter what.
Yeah, no, that's really interesting. And David, I mean, just looking at your slide earlier, it looks like you're really trying to minimize the complexity, even just looking at it. I mean, is that kind of with the customer fear of added complexity for no massive gain other than CO2? I mean, what's the thought process behind your approach?
Yeah, so especially because we've been targeting companies within the United States to go after to start with, where you probably have the biggest delta out there between electrical costs and natural gas. So you really need that high performance. So they all view heat pumps as probably the main thread carried out between every customer that we talk to, and everyone we were at RTC is heat pumps were the common thread between these. Now, what I think we've had to do with some of our customers that we've been talking with is educate them that you actually can beat out natural gas today if you tie in with the waste heat stream and you get the higher efficiencies, as well as that, if you are using kind of the more legacy solutions out there, if the CapEx is too high, you never have a payback period on that. And so we've had to do kind of a little bit of an education of why our approach is very different than the systems out there. Again, echoing Dolph and Michael, it is about demonstrating it. So we're planning to have our first system in our facility up and running in Q2 next year. So that'll be 8 months after we started the design on that. So we're sprinting towards that to be able to get a system out there that they can come touch, feel, see it running. But to the point of, I think a lot where there has been historical concern is a natural gas boiler is very simple. There's almost very little operations and maintenance. Every solution out there today, if you're using commercial off-the-shelf parts or you're using the legacy solutions, those are not that. And they are deployed places and you need to do regular interval maintenance. That scares, I think, a lot of people within the food and beverage industry because they're not used to doing that. So in the fork in the road decision that we made as a company is we can go the easier route on a technology side that requires that regular interval maintenance. And we're going to have to train a workforce to be able to do that. We're going to have to train a workforce to be able to go install these systems. Or we can put the work on us as a company. We can integrate all the newest technologies out of other industries that have created, you look at a car today versus like an electric vehicle versus what it was 20 years ago. You had a carburetor, you had to do oil changes, you had to do all this stuff. Electric vehicle, you don't do anything. And that's what the consumer's used to. And that's what we're pushing our technology to is a set and forget for 20 to 30 years. You don't have to do any maintenance. You don't have to do any regular interval overhauls. And that's what I think gets our customers excited about our solution.
Yeah. We've got high gas prices in Europe, David.
We'll come there soon, don't worry.
So maybe Victor, if I could turn to you a little bit, sort of, I know we were very brief over kind of what you look for, but capital, I mean, I personally, I think heat as a service will take off. It has to, and it'll be cultural maybe, but your ability to finance it, I think is the key, right? And I think listening to what we've heard kind of so far, what do you think, from an investor's perspective, needs to kind of happen? So for this to become something, not just I'll finance 4 or 5 little projects, but, hundreds of them.
No, absolutely. So, Susi's done a lot of bespoke energy efficiency projects across Europe. So it's not that doing bespoke projects can't be financeable. What's important is just around some of the technology risks and contractual risks of it and counterparty risks. And so a lot of heat pump technologies that exist today, and you kind of heard it through the panel today, are still getting to that TRL kind of level and moving beyond pilot to proving technologies. And I think to make the heat as a service kind of work, there needs to be an integrated sort of guarantee that the end customer gets. There needs to be guarantees around the COP or guarantees around the quality of the steam. It can't be that the end customer has to take over those risks if you're providing it as a service. And so there needs to be an integrated element in terms of what is being provided to those end customers. The other element is just around the end customer risk. Clearly they're looking for a financing solution because they don't have enough capital themselves to be able to integrate this. And so the counterparty credit risk is an important element to kind of consider. It could be kind of structured in different elements, but those counterparties need to be creditworthy for us to want to finance those systems. And there needs to be the right sort of contractual protection so that if those counterparties change their processes or close shop earlier on, that they still need to make whole those equipments that we financed, or that equipment needs to be movable so that it could get deployed to another site. So that's another kind of critical element. And maybe the last point is just around, let's say, it will take off when, let's say, certain technologies will be fit to customers. The COP levels are important depending on what the quality of the waste heat is and how to recover it. And so I think specific to heat, unlike with energy efficiency as a service, for us to offer those guarantees, there needs to be reliability around what's the processes that they're doing, what's the waste heat, what's the electricity price. It wouldn't be necessarily something that we would want to finance that risk. We could finance the risk of providing a service and having an ESCO that provides that service, or a technology provider kind of provide the service, but we cannot, like the financing solution cannot take over the risk of the end customer's processes, cannot take over the risk of the end customer's usage profile and electricity price kind of distribution. So those make the feature much more particular compared to just financing a rooftop solar system or financing an LED lighting retrofit, which is a much more clear sort of efficiency model that we've seen.
Yeah, well, but solar was complicated in the very, very beginning, right? And it's now a commodity. So hopefully we could do that. While we were, I think, speaking, Victor, a question came in on, do you have projects that you financed here in Europe?
No. So all like most of the 800 million euros that we financed are in Europe, and we've done some heat pump kind of projects already. That have also included kind of a rooftop solar to help balance, let's say, the electricity price risk for that customer. The range of projects that we've done have been around, LED lighting systems, broiler systems, electric boiler systems as well, waste heat recovery kind of efficiencies, HVAC systems, a whole range of energy efficiency measures. And I think heat is going to be the next blue ocean of opportunities. It's well known in Europe, a lot of the natural gas comes from Russia and now Norway. And if we want to decarbonize that and kind of remove our reliance from those sources, electrifying heat is going to be a huge opportunity to kind of help those customers do that.
Perfect. And Dolph, there was I'm just trying to respond to some of the folks that are coming in. One wanted clarity on your current project. The Belgian brewing actually, ironically, is actually in Colorado. Not Belgium, right?
That's correct. They're called New Belgium, but they're based in the US. Yeah, so the first facility that we're going to deploy our system is in Fort Collins, Colorado, which is very convenient to us because we're also located there. So it's within a walk's distance. Yeah.
Yeah, no, absolutely. Okay, great. Listen, Victor, thank you for that. I think that's really interesting. Maybe Michael, if I could come back to you and also to Blaine on this idea of heat as a service, because right now I think, as it was mentioned before, you buy a boiler, you don't really need a maintenance guy. It's sitting in the middle of your facility and it's giving you what you want. It's been doing it, I don't know, for 10 years, and it doesn't really need much, bothering about. But when you start to come up with a more complex system, and you have it on your premises, and your service guy is off premises, or maybe, talk me through a little bit of because I think ideally we all want to go to heat as a service, right? But I mean, I think there's certain challenges or paths we need to get through to get there. And maybe talk a little bit about kind of what you see are the issues. I think it's, having other people on your premises, or, not knowing how to fix it myself. I don't know, but maybe talk us through that. Maybe start with you, Michael.
Yeah, I think one of the aspects when it comes to the heat pump, high temperature heat pump, is it's basically more complex. And in a way, once the heat pump is delivered, the main work starts, right? Keeping it in operation and also maintaining the efficiency, which is guaranteed. And that is, I think, the bit of difference compared to boiler. There, basically, the work stops once the system is delivered, and you just turn it on and off. Very simplified that. But so I think the customers we are seeing here, we have now, for example, delivered the heat pump now around 6 months ago. The guaranteed COP was around 3.5, and then once we were on site, we were showing the customer, but if we do this and that, and all, you modify a little bit your production process, to the better, we get a COP of 6, and they suddenly got very excited. And they are really welcome us to the site, and we are open discussion how to do this. And of course, an efficiency gain from a COP of 3.5 to 6 is significant. And that's something also when we see, okay, once the heat pump is delivered, you basically start the customer relation when it comes to heat as a service, and it opens up a lot of opportunities, not only for us as a heat pump owner and operator, but also for the customer in really further developing and their production to be more energy efficient and achieve their ESG targets, right? On other aspects, what we saw in the Feldschöpfe project, there was always coming smoke and a little bit of dust out of the factory, which was an odor to the neighbors. Once we have installed our heat recovery unit, we have much less smoke coming out of the pipe, and as well as the odor is reduced. So that a lot of aspects like this we see now that is happening when we are working together with customers through heat as a service, for example.
Okay, Blaine.
Yeah, this is an important topic, and Victor and David have identified some of the, and Michael have identified some of the key issues and opportunities here, right? But so there simply isn't enough CapEx to make the transition to a net zero world, right, or to stay within our collective climate targets and sustain business. There simply isn't enough internal CapEx available at the right pace to make this transition, so this represents a shift. Shifts are always scary. There's always some friction, right? Because we're going to learn some new ways of managing these issues. I think the renewable electricity experience is massively instructive here, right? Because I used to be in that work, and can recall going to companies and whoa, PPAs. That's not how we buy electricity. We don't. 10, 15-year commitments. What are you talking about? And what do you mean that the project's 4 states away? Whoa. On-site, so we're not going to own the ad, right? It took a minute. But a couple things happened. Collectively, the big collective, we got collectively very good at understanding and pricing the risks. Inherent in these transactions, right? And understanding the risks and understanding the returns, which made it very attractive for third-party capital. There are lots of investment grade counterparties in this space, right? I mean, back to my members, they've all got fantastic credit, right? That's part of the asset they bring to bear here, and I think you even had this on one of your slides. It's a risk management question, and one of the things that can be done here is we can collectively identify all of the risks in a heat as a service kind of contract and price them, and we can make decisions about, okay, you want to wear this risk or you want me to wear it, well, fine, and the price of one's right. And so here it becomes the contractual assurance of all this, I think, ultimately becomes an asset rather than a liability, right? Oh, this is different and challenging. No. We're actually going to put some security and some assurance around what would otherwise be unsecured energy procurement transactions.
Yeah, I think that speaks, Victor, to what you were talking about earlier, is really analyzing that, and those risks actually become opportunities because you price them. Right.
Absolutely. And I think what potentially, from a scaling point of view, it's not every customer has the same sort of demand. Whereas like consuming electricity is pretty standard. But when you need different grades of heat or steam, or where your processes are seasonal, or let's say if you're using air-based kind of heat pump, where your temperature is also different, and so there's complexity in designing something that's fit for an end customer. But it could all be priced once all the risks are known, and it's transparent in terms of which risks are associated to who. It's easy to finance these things. I think it also requires, let's say, developers like Anyos, or sometimes it's the end, like the technology themselves, to go to those customers and help design and want to implement their systems. And then finally, it's the CFO to agree to sign up to this as a service sort of solution, and let's say the process managers to run the systems themselves. Because right now, they're taking the energy risk themselves in terms of what the natural gas price is to run their systems. And so the moment that they're able to make that leap, then it becomes financeable very easily.
I see also where the heat as a service model fits in today is going to change over time as well. To Michael's point, where you said that like when a heat pump is installed, that's when the journey begins on maintenance operational. It doesn't need to be. Nuclear reactors run for 20 or 30 years and you don't have to touch them. So really that's like a technology problem. I don't view that as a business model problem of it. And so I think heat as a service right now, if you look at a big multinational company, they can pay for them all they want. What they don't like is the risk of, we don't understand the maintenance of this. And so I think there's a technology piece that will help unlock the ability for these companies to pay for these just outright. Because I think also there's the aspect of the performance of the systems today give you a payback period closer to 10 years plus, or potentially in some cases, like almost life of asset, you never pay it back. So if I'm Pepsi or Coca-Cola, why would I spend my money on that when I could put it in the stock market, or I could put it in a money market and make more money on it? Where their targeting is in this 4 to 6 year payback period on any type of technology. If you can hit that, now they get really excited to spend their money on that piece of it. But there will always be this long tail of smaller companies that are a huge part of the market as well that just don't have balance sheets available for it. So I think as we look out, it'll actually become a little bit more like traditional financing for the people that don't have these huge, like these very strong balance sheets. But right now it's almost like a hedge, because I just don't understand the technology. I think there's going to be maintenance associated with it. But if you can reduce that piece of it, and you get them comfortable with that this is a true replacement and it's actually very similar to your boiler and it will be set and forget, they know how to finance that stuff. They know how quickly they can get a payback if you have a high performance of it.
Well,
a lot of unknowns.
Building on what Blaine mentioned, I like what you said, Blaine, around we can learn from the renewable PPAs. The big difference obviously is that heat is less movable. So I'm interested to hear from Victor maybe how you see the credit risk. So not so much the technology risk, but the credit risk for financing a system that is, highly integrated into a factory and is not per se removable. How do you think about that risk if such an off-taker becomes insolvent, for example?
I mean, it has to be, priced appropriately. But we would look for kind of shorter duration kind of contracts and payback periods. But the counterparty credit risk is an important component, and it's not. I think with heat in particular, it's not that processes could change, right? For some companies. So there needs to be the right contractual provisions such that if they do other wider services or change their processes, that they need to continue kind of like it's a take or pay for a certain amount of heat that should have been provided if they're not consuming it, let's say. And so that it has to take into account the variability of processes. With renewable energy, indeed, if you have solar on a roof, you could just inject into the grid and not be so anxious around the counterparty credit risk. But I think Anyos and Michael, you were probably going to say something with your experience on this as well.
I think for my experience also, it helps a lot. It's all about a lot of risk management and so on, right? And in order to get basically the idea also that our clients are open for heat as a services, if we could also offer basically joint ownership on the heat pump project, so that both parties have the same interest and the same ownership in the risks, and also the interest in minimizing the risks during the operation time and so on. So joint ownership through energy as a service or heat as a service might really help to basically smoothen the way, even the path for this kind of energy as a service model for the future. It helps a lot. It's basically like a marriage. So
yeah. Maybe turning it a little bit, you mentioned payback, and I think that adds return, and return, can pay for risk. And I'm just thinking, you know, we're still at the early stages of our industry, and just to kind of put the finger in the air a little bit about, you know, as you grow your businesses, you know, the biggest part of the expense up front, kind of what we saw in one of the earlier slides, it's the capital, right? But as you start to build, you standardize, you get a broader supply base, you know, you're doing bigger numbers, you know, there is a potential to bring costs down, right? So then that, you know, allows you to sort of, you know, drive up the returns or, you know, reduce prices for customers. But I think in a way, getting finance, you also have to kind of, you know, the end cost of heat for the customer is a critical piece of it. And that upfront component that we've got is the capital cost. And I would just, you know, wonder actually, what sort of potential do we see around the table? I know, you know, you've all mentioned cost in one way or another, but maybe start with you, Michael, and go to Dolph, Andrei, and David, just in terms of, you know, looking forward, is there a 20%, 30, 40, 50%? Maybe it's not what solar did, you know, but what kind of potential is out there?
Potential for cost reductions, you mean?
In capital costs particularly.
Yeah, that's a good question. I remember 10 years ago, I was suggesting once to build a heat pump for around 200 euros per kilowatt installed thermal capacity. And everybody in the audience was basically laughing. But because we know from the refrigeration units where we basically have adopted a lot of the technology, what is actually a realistic price range for standardized units, right? So I guess it will be somewhere in the range of 500 to 1,000 euros per kilowatt installed capacity. Currently, I guess most of high temperature heat pump suppliers are beyond that. But by selling more and more units, standardizing the components and also the integration, that helps really to bring the costs down to, in my opinion, below 1,000 euros per kilowatt shouldn't be a problem in very nearby future.
Okay. Dolph, I think you're designing your system to be low cost, right?
Yeah, I think it's actually kind of funny that more than I'm going to say like 3 or 4 of us have wind turbines in their background. So I think it's essential that we get this heat pump technology on a learning curve, just like we did with solar and with wind turbines. And the only way that we think we can do that is to mass manufacture these units in factories. So by deploying more of them, you become smarter about how to do it. And then secondly, our belief is that we can reduce and in some cases almost eliminate the installation cost by having such a modular unit. So you eliminate the installation cost or reduce it significantly. And then by just making more of them and mass producing them, just like I guess what 100 years ago Ford did to cars, we can get the capital cost of the system itself down as well.
Yeah, because we've seen it in wind, then we saw it in solar, and then we thought, wait a minute, are we going to see this in batteries? And we've absolutely seen it in batteries, particularly this year. I mean, it's been you know, LFP has just gone through the floor, right? And so, I mean, maybe we're a more complex business, but there is, I would say, you know, every forecast of cost reduction has failed, but on being more expensive, right, than what actually ended up happening. So I think it's good news for I guess, heat as a surface camp. Good news for you, Victor, right? Hopefully.
I mean, I think we're targeting, we're quite a bit below what Michael is hoping is the target, you know, for this industry. I mean, we're targeting 60 to 70% cost reduction over what the standard is today. And a lot of that is just due to a much more compact package. Elon calls it the idiot index of like, what is your raw material cost versus what is it actually cost? And a lot of that is associated with that we have 1/3 the size and we can do this much higher lift per stage, which is really just leads to a dramatic decrease on the CapEx side of this. But again, like I think people focus on performance or CapEx and they go hand in hand. You have to have the high performance so that you can show a cost decrease over your natural gas solution today. And it needs to be paired with a low enough CapEx that you pay it back in 5 years. That's really how you do this piece. And, you know, that's really the goal of Carmen, as well as then to Dolph's point, like these need to be mass manufactured in factories. We can't have the legacy solutions that some of the big players out there will say, well, great, we'll build you a custom bespoke solution. We're going to ship all the parts to your facility and we're going to assemble it there. That first off, you'll never be able to hit 700,000 boilers globally, as well as then each one is treated like that integration, that, you know, the hidden integration cost that Dolph was talking about just goes through the roof. Your EPC cost, your actual integration dwarfs the CapEx piece of this. So these need to be stamped out in a mass manufactured way where most of the assembly is already done when it comes on site. That's what gets customers excited.
Yeah, no, absolutely. Andrei, any thoughts on that?
Yeah, we've been thinking about this design requirement of making it simple and making the end cost low from day one. Essentially, in our machine, we are probably the first, as far as we know, to remove all sliding seals, all membranes and bellows from a Stirling engine that works. What you get in a Stirling engine is that you're manipulating 50 bars, possibly 100. So every move you make basically has a very high power density. Just as David mentioned, it's very important that everything is compact. The other thing that we have is essentially all the work is done by bearings, and bearings run at very low speeds, like 1200 RPMs. That's enough. That's enough to get power density. And if you have cold bearings running at low speeds, that's something customers know will not need maintenance. It's something they know it exists. It's been on trains, it's been on elevators, it's been on everything. So we really put all the complexity, we shove it down into a place where we know it will be sorted out. And we did that from day one. Also, to the point of cost, I know that there's been this whole pressure about we have to be cheaper than natural gas, and natural gas can get very cheap, and we don't know what the future will be like. Will there be a big economic crisis? And will Europe open to Russian gas again? What will happen then? But then you have other ways of thinking of this. For example, you have this huge pile of money sitting on essentially AI and all the Amazons and Microsofts. And they are concerned about their footprint. They're so concerned that they're ready to pay $3,000 a ton for a direct air capture, which seems crazy, right? But to them, energy is tiny. The big part is the GPUs. That's what's expensive. The energy is small. But if it's just a 2-3% impact on their image to get energy sorted out, they can pay for it. They don't care about the cost. You just have to be with them, because DAC, it's something where you have to cycle up and down a piece of adsorbent, and you can't put it on the belt. It just doesn't work because you have to put it in vacuum. So you have to do all this temperature cycling, which no racking system can do, essentially. So if you go after those opportunities, cost is not a problem anymore. But of course, we know this is just one market. We're not betting everything on this, but there are avenues, right, to just bypass the whole problem and channel the existing forces of the world to basically get this massive wave of adoption where you can get to scale, you can get your costs down, you can get millions of hours of operation, and then it becomes something standard.
Yeah, that kind of, Dolph, when you showed your slide in the intro, you know, you talked about, you know, also applying it to cooling. Did I have that right? You know, and then of course, data centers, you hear that what a ChatGPT query is 10 times the amount of energy than a Google search, right? So I don't know if ChatGPT is going to take it over, but it means the data centers have a big problem with cooling, right? And we've talked to some of the players in the renewable storage or the heat storage side. They're already thinking about this. And I think, to Andrei, to your point, you know, where's the pain point really going to happen? You know, so maybe that's something there. We're coming up with a little bit of time pressure. I thought we got another like 6 minutes or so. Maybe a parting question would be, and I know a number of players from the thermal storage sector are kind of listening in. They're very curious as to what you guys are up to, which deservedly, right? And we've heard that, you know, is it a competing technology? Is it a complementary? You know, as a banker, I thought it's complementary in the way that you take heat and you make it better heat. You know, they take heat anytime you want to give the excess power. So they've got this cost advantage of being, you know, only need 4 or 5 hours a day. Give it to me whenever you want. I'll take negative price. I'll take flat price, you know. And you're, on the other hand, you can, and I'm just wondering, it sounds complicated, but maybe there is, because there's 2 different angles to this. And so far I've heard kind of guys that think, yeah, it could work, or others it's like, whoa, that's complicated. Let's get heat pumps off the ground first, and then we'll talk. So maybe go round. Let's see. Maybe Michael, start with you.
Oh yeah, that's a good question. Now, for me, it's a bit complementary, but I don't really think that heat pumps, high temperature heat pumps, are competing with thermal storages. The ideal process for a high temperature heat pump is basically a production site that operates for 8,000 hours a year plus. And that basically means also the production stability and requires basically no thermal storage, because the excess heat sources and the heat demands are always there matching. So I see in particular for heat pumps where which we start up once a week or so, let's say 50 times a year for the startup period, the need for thermal storages. But that would basically need, then we need a storage only to use it once a month, once a week. And that's maybe a little bit too costly to do. So, but there are opportunities to combine it. But for the best heat pump cases with the highest operational annual hours per year, I don't necessarily see the requirements for thermal storage.
Okay. I don't know, maybe going right across, maybe David, you got any thoughts on that?
To Michael's point, like I don't think it's necessary, but it helps. If you have thermal or lithium ion and you want to help level set your fluctuating electrical costs, great. But at the end of the day, whether you have lithium ion that then power an electric boiler or you have thermal storage, you're still getting below 100% efficiency. So when you pair that with a heat pump, now you're talking 400, 500, 600% efficiency. So why would you not put them together? I think you should always do a heat pump. You sometimes may want to do thermal storage or lithium ion, but you would probably, in my opinion, you would never just do lithium ion storage or thermal energy and ignore the heat pump, because you still have that same problem of like, you're just wasting all this very usable heat out the roof.
Yeah.
Why not grab it? Why not make it more efficient? You can downsize your thermal storage. You can downsize your lithium ion, and all you're doing is just helping level out your actual energy costs on it. But you still want to make the best use of that heat once you have it.
Yeah, that makes a lot of sense. Andrei and Dolph, maybe any thoughts on that?
Yeah, it's a very interesting technology. You know what's happening in heat storage right now. Basically, their approach is the grid is about to shift, and we don't feel the pain of how much it shifts yet, but it's gonna happen. It's gonna be more and more electricity, solar electricity, more and more wind power, and all of that will be all over the place in terms of time when it happens. And so there will be a few options to do this. Either you store as a production site or you store at the consumption site. And both can be valid, essentially. The big difference to me is, do you have a big grid connection or not? If you need 10 megawatts of heat, you can either have 3 or 2 or 5 megawatts of to power a heat pump, or you need 40 to 80 megawatts to have the heat storage. On the other hand, as I remember, there was a person from Antora during the who was dealing with finance and regulatory affairs during RTC. She said 1/3 of large US factories have access to $15 per megawatt hour of electricity 8 hours a day, most of the time. And that's huge, right? You basically don't pay for electricity anymore. If you have access to the connection, then it makes total sense. So I think it's a huge pie, and some people will be better suited for storage. Some people will be better suited for heat pumps. There's a bunch of cases out there, a bunch of temperatures. So we can totally coexist. As I mentioned, in our case, we actually amplify them. Yeah, it was Carol and Joe. Thank you, Blaine. In our case, we can actually amplify the heat. So even if price fluctuations smooth it out, and for some clients it's almost profitable to have thermal storage, we can make it profitable, and they know it. We talked with them. They know we are an opportunity for them to grow larger.
Yeah, no, that's great. Dolph?
Sure. Yeah, I think it's a good point that Andrei made, the grid connection. So I used to work with Antora Energy myself, and here in grid congested the Netherlands, I believe we have the most solar PV installed per capita in the world. It's a nightmare for factories to get an upgrade in their grid connection, or sometimes even to get a grid connection at all. So the grid, what is happening is that the grid cannot catch up with the
Yeah.
increased deployment of renewables. And that hurts the business case of a thermal energy storage or a lithium-ion storage solution, right? If you really need to be able to soak up the power quickly, thus a grid connection for the economics to really work out. But I do think, I mean, what we see happening at Mozero is we see some of these thermal energy storage companies approaching us because they see a good combination of heat pump and their thermal energy storage. So there are definitely cases where the economics do play out and the grid connection is not an issue, and they can pair up with our heat pump solution.
Yeah, no, I agree, Dolph. And we've on our side seen many cases where the storage guys are actually starting to provide grid services, right? And instead of just selling steam, they're getting money for grid services. And also they can pick up on the, very low prices, right? So it kind of gets into almost the trading side of power. But anyway, I think we're coming up against time, and maybe this has been brilliant. And could it maybe Blaine and Victor, maybe just some kind of closing thoughts from you two, just kind of parting thoughts rather.
Yeah, this has been a fantastic discussion. Time well spent. I guess the thing I would offer in closing is that the demand side of the market here is growing, right? And growing steadily. More and more companies are raising their hands and saying, listen, I got to go. Me too. We've got a goal. We've just set a target. Our customers are pinging us because we're in their supply chain. We're suddenly having to wrestle with these issues. What do we do, right? I get calls from guys saying, what do we do about this? So for investors, for solutions providers, the growth in this market is going to be substantial, and it's going to be full of creditworthy counterparty, full of the customers you want. There is a ton that can be executed in the next 2, 3, 5, 10 years.
Yeah, thank you.
And let's say this is wonderful to hear. This is what let's say capital providers like Susi want to do, and I think part of it is moving from the pilot project and being able to touch and feel to mass producing and deploying it. Like, I think the capital is there to help scale, like it helped scaled solar. We need these technologies to kind of move beyond the pilot phase, and for there to be developers or corporate customers that want to implement these solutions, and capital flow to it. So it's certainly a blue ocean in terms of opportunity.
Yeah, brilliant. And maybe just parting comments from the companies, Michael, David, Dolph, and Andrei. Michael, maybe?
Yeah, no, I'm always pro heat pumps, so it doesn't matter. However, I think the market is really large enough and the opportunities are endless right now.
Yeah.
We hope we see a lot of interesting heat pumps coming up in the next 1, 2, 3 years. So really exciting times for being in this sector.
Brilliant. Dolph?
Yeah, well, thank you, Andrei and Victor, for setting this up. I think this has been a great conversation. And I just want to maybe, as a few closing remarks, there is a lot of demand for these types of solutions. We are actually struggling to keep up with our manufacturing capability ramping up. So we're starting series production of our products in 2026. And we're already looking at how we can increase our ramp up of our manufacturing capabilities. So it's a good sign. And I think we're about to hit this inflection point in our industry.
Brilliant. Andrei?
Yeah, it's Airthium has been around for a long time. We were in energy storage, then went in seasonal storage, and then went to heat pumps. When we moved to heat pumps, nobody was talking about it. And then it happened, and then it just got bigger and bigger. So we're at the right place at the right time. We definitely feel it. We get all this traction, and we have the technology to deliver collectively. We have all those different approaches, and they actually work together. It's a blue ocean. So I think next years are going to be really exciting.
Brilliant. And David?
I just want to say thank you, Andrei and Victor, for putting this together. This has been a great discussion. Yeah, I mean, this is we see this just like everyone else does, this massive wave towards the end of this decade of a lot of demand for heat pumps. And we're gearing up, just like Dolph had said as well, and planning for what that production number looks like for us. And we have actually a couple slots left for 2026 deliveries. So if you're interested, feel free to reach out.
Great, great, excellent. Well, listen, I'm honored on behalf of my Victor, myself. We've got 2 Andres and 2 Victors on the call. That doesn't happen that often, I can assure you. But anyway, I wanted to thank you all for the time. I mean, this has been, from my perspective, stimulating, and we're getting a lot of feedback from people who've dialed in. So that's been absolutely brilliant. This will be on our website, the recording, and any materials, and we'll pass any questions along to you guys. But really, thank you. I think you put this, put heat pumps, you've taken it up a couple notches in people's attention span. So well done. Thank you. Take care. Bye-bye.